All right, guys, so I have a question about how do I determine, this is related to number 19 and the chapter 1 review problems. How do I figure out the domain of something like, well, let's see, let's start with this. Right, let me give it a little name. What's the domain of the ln? What's the domain of the natural log? Just in general. Greater than 0. I love it. You should, when I write natural log, you should be able to call up an image of its graph in your head. Right? It's one of those basic graphs you should know. And then you learned in pre-calculus, hopefully you learn how to translate that thing, right? Natural log of x plus 1, it would move back 1, all that kind of shit. So you got to know what the basic look is. And this pretty much helps you remember the domain. So the inside greater than 0. So what if I had this? How do we figure out this guy's domain? The great thing about domain is if you can say in English what needs to happen, you translate that to Macish and solve it. So what did I just say must be true about the inside?
X equals 0.
Not equal.
Greater than 0.
So you say to yourself, inside greater than 0. Inside greater than 0. And then you solve it. That kicks so much ass. Right? So then this x greater than negative 2. Is that cool? Now where it gets interesting is, what if I had this? Sure. Oh. Really sorry, I'm constantly sniffling. This doesn't really help a lot. What about this thing? Obviously the first step is what? Yes, okay, there you go. Inside greater than 0. Now you worry about what the hell it is. The first step is just inside greater than 0. That's what the domain requires, right? Now I have to figure out how to solve that, and you can't add 25, take a square root. That's not quite right. It's not going to give you the right answer. I love people that do that, and then magically the right answer appears out of nowhere. All right. So there's a few different ways to think about this. Do you guys remember? All right, let me show you the very technical way to do this, and then I'll show you a little bit quicker way, graphical way to do this. So obviously somebody yelled at me factor, which is a really good idea, right? How do you factor that? Okay, I like it. Now here's the thing. This is an inequality, not an equality. So you can't solve it the same way you would an equation. What does it say? That function has to be positive. Yes? Okay, so when is this function 0? At 5 and negative 5. That's where it's 0, right? Do you guys remember doing this kind of thing with the number line? You investigate the signs. Does that sound at all familiar? We're going to do that several times for several different kinds of things, but it's all going to be basically this idea. So if this doesn't look familiar, everybody's cool with the fact I could just say, okay, that says this must be positive. That's greater than 0, positive. Here's where there's 0. What is it here? In the middle here. Any number in the middle. Yeah, in there it's negative, correct? So if I put a 0 in, 5 times negative 5, it's negative for every number in there. Do you guys understand?
Yeah, I remember
that. Yeah, because the only place it could change signs, the only place a function can change signs is around where it's equal to 0. If it's positive over there, it goes through 0, it could become negative on the other side. So these are the only locations where it might change sign. So those 0 locations are sort of like doors. It's negative here. If I go out here, put a 6 in there, what do I get? Negative or positive? Positive. And of course out here I get positive. So now where is it greater than 0? Yeah, before negative 5, right? and after 5. Now, the other way you could have thought about this is, oh shit, you guys can yell at me if I don't do that. The other way to think about this is, isn't this just the parabola? Shifted down 25, so it's going to go through 5 and negative 5. Where is it positive? Bam! Out there, above 5, below negative 5. Bam, got the answer. So when the function I'm dealing with is something simple to think of graphically, you can do a graphical method to answer the question. Okay, maybe. This could be related to a problem you have to do in the homework. Okay. Anything else from that first? Oh yeah, there was that one question I want to do. Let me do this, and I'll see if anybody else. Here's a beautiful question. Has anybody looked at this thing yet? This one. Anybody?
Yeah.
Yes? And you're all like, we are right now, Jeff. Okay. Now, obviously, I cannot fault you if your first instinct is to try to find the inverse function. Can you guys see that you're not going to be able to do that? Do you guys remember how to find the inverse function by hand? Okay. So quick little review of inverse functions. Yep. Oh shit. So I'm not really used to using this projector, but I think because of the way the room is, I'm basically gonna have to. So please, dear God, don't hesitate to tell me. I'm writing all this shit. So somebody go, we can't see it.
I knew you'd know this.
Oh, thank you. Don't have that much faith in me. Okay. Zoom, focus. Okay. So for example, if I have this function here, what is it, Jeff? Oh, that looks nice. Ooh, I like it, yeah. Does anybody remember why that's invertible? Why is that even invertible in the first place? What has to be true about a function for it to be invertible?
Vertical line.
That's for it to be a function.
Horizontal line.
There it is. All right, I love it. You know, it's one of those two. So vertical line test tells me it's a function. Horizontal line test. Now, why does that make sense? Because when I take the inverse of some function, don't I flip it around y equals x? So what we do is, instead of flipping the function and then doing a vertical line test on that, we just do a horizontal line test on the freaking original one. That's where vertical line test comes from. I mean, horizontal. It's just a vertical one flipped. Okay, maybe. So cube root, I don't know if you guys know what it looks like. A cube root looks like this. It definitely passes vertical and horizontal. It's got an inverse. Anybody remember how to find the inverse by hand? Anybody? Say it one more time. Good. Switch x and y. It's so beautiful. When you first learned inverses, hopefully your instructor graphed something and then said, how do I get the inverse? Switch the x and y. You switch the x and y points and you get this neat symmetric graph. Does that sound at all familiar? They look like Nazca lines. Anybody know the Nazca lines down in Peru? All right, it's okay. You don't have to know them to be able to pass calculus. Don't worry. So what I always do is, me being weird, I put little dotted line there because I didn't just do something algebraic. I applied a concept. So I just have to put the dotted line there just to remind me I didn't do shit to make that happen. I applied an idea. And then what do you do? Of course. Yeah, solve for y, right? Because now it kind of makes sense. In the process of solving for y, am I not going to undo all the operations? Isn't what that the inverse function should do is the opposite of everything the original one did? So now I'm going to add 2. I'm going to cube. Is that cool? I'm going to skip some steps, and then I'm going to subtract 1. You guys still see all that?
A little bit.
Thank you. All right, now, so that's in general how to find the inverse of any function. Okay, let me let you guys finish. Everybody got that? Let me go ahead and put this down here. So the one that's in here is that function. Can you guys just think in your brain, if you switch the x and y, could you possibly solve for y? Let's try it. Let's see. So if I put the y back, hey, if I switch x and y, my ln wants to become a single. Okay. Can you guys see that that just ain't gonna go nowhere? Just to show off my awesome grammatical skills. All right. Cool. So what the shit? How do I do this problem then? Wait a minute. Let's look at the problem. What do they want me to do? It wanted me to find f inverse of 2, and I can't even find f inverse. No? Yes? Right? So here's something that's you're not used to. You are completely allowed, and you are required to guess. Right? So they want to know what this is. What does this mean? What is that really asking you to do? Don't tell me find the inverse of 2. I can read that, but what is the idea behind it? Yes?
2x plus ln x equals 2.
Yes. Right? For the inverse, the input is the output of the original, of course, because that's the whole idea. So it's asking you, where is this equal to 2? And don't say the answer. It's kind of obvious. Right? What's the nicest output for natural log? Yeah, and when is that? All right, stop. I'm not going to say anything else. That's it for me. You guys understand that? So at least I want to stop you from going insane trying to find the inverse. You're not going to do it. Actually, if you do, come see me. I want to see that. All right. I want to see what you got. Okay. Anything else from that first? Is that enough, guys? Any follow-up questions? Is that all right? You guys get the idea? You can't find the inverse, so don't try. Okay. Anything else from that first? Okay. All right. So what I'm going to do, now that I was able to get in here early, don't worry, I'll switch over. I want to talk about section 2.1, and then we're going to finish up some stuff in 2.3, and then I have a handout that I want you guys to work on. So let me switch this over. Oh, what was it? Was it that one? No, it's this one. All right. I do love Desmos. Somebody yelled at me the other day about not using Desmos. I just couldn't get in the room to set it up. Have you guys ever used Desmos before?
Oh, yeah.
Yes? Okay. And I don't know if you know, I mean, it's pretty simple setting up sliders like this. But what I've set up is I've got this function, and I'm curious about the slope. Let me set this up. Why didn't I put this where I wanted it to be? I want the slope at 0. So that blue line is the line that we don't know yet how to calculate. Right? That is the answer. That's the tangent line at 0. That is the line that has the same slope at 0 as the curve does. So that's our goal. I'm trying to estimate it right now by using these points. Right? I've got 0, 0, obviously, and then I've got this point. What point is this? Well, it's 2, 2. Can you guys real quick figure out the slope of that? I mean, you shouldn't even have to do work. What's the slope of the line from 0, 0 to 2, 2? 1. And what do you got here? 1. All right. Now watch this. Is that the right answer? No. It's too what? Too big or too small?
Small.
Too small, exactly, because the blue line obviously is much steeper.
Yeah.
So of course the answer is to bring this in closer. The closer this gets, the better the approximation. Now real quick, would you say this is a nice function?
Yes.
Oh hell yeah, this is a nice function. If I was on this plane, there would be, we're gonna take a turn, we're turning and we're fine. Now what about something like this? Whoa. Do you want to be on that plane? Now, do you understand then? I really want you to understand what I'm saying. The idea of close really depends on how insane the function is. If it's kind of a nice polynomial, I could kind of be further away and get a decent estimate. But can you imagine if it was going like this, right? The minute I'm a little bit far away, it's whatever the shit. I got to get really close then. So the idea of close kind of depends on what the function does, right? How kind of crazy it goes, how quickly its slope is changing. So if I take a step in, no, Jeff, got it, stop it. If I take a step in, let me come up to 1.5. There we go. Can you guys verify that for me? Do you see the slope it got? 1.25. Are you guys all able to see that? You have better vision than me, possibly. Okay. Can you please take a minute and verify that? Make sure this thing is doing the right work. Do you know how to verify it? So this line right here, it goes through the point 0, 0, and it also goes through the point I don't know yet. So if you can figure out what that point is, well, how do you do that? Well, I know the input is 1.5. I'm 1.5 away from 0. You guys with me? So the input is 1.5, and you got the function, you should be able to get the output. So, I love you guys. I know that the slope, yeah, the slope is y2 minus y1 over x2 minus x1. All right, let me see how I can do this. Let me just do one of these. Right? Pretend like this, that's what this says. So if my x1 is 0 and my x2 is 1.5, let me just do this. Is that cool? You understand? So I got to calculate what the y's are, and then I can just throw them in the slope function. Do not let this kind of problem be difficult. You've got the function, you can calculate the y's, right? So the function again was negative 0.5x squared plus 2x. Right? And I'm dealing with the points 0 and 1.5. Okay. So go ahead and calculate the slope. Make sure that Desmos got it right. You never know. They could just decide to say, screw these humans. I'm going to give them shit answers and see what happens. You never know.
Yeah, that's right.
Yeah, we know it's right, but I want you guys to do it. Because this is what you're going to have to do in the first homework assignment in chapter 2. Exactly this kind of problem. So let's see. So get that. What is f of 1.5? Is it 1? 1.875? That sounds better. Okay. 1.875. Of course, f of 0 is 0, and 1.5 minus 0 is 1.5. I like it. And then when you do that division, what do you get?
1.25.
1.25. Okay, so Desmos got it right. Let's come back. 1.25. I like it. And then, of course, so the whole idea is we want to just keep making h. What is h, by the way? What is h physically? What is h in this whole thing?
Like this is like,
Yeah, so I've got the point that I want to know the slope at, I need a second point to be able to do algebra, right? So then I just go h away from a to get a second point. And the closer h is to 0, the better my estimate becomes. So then I'm just gonna, let me see if this will do what I want it to do. All right, I like it. Let me do this. Get out of there. Let me kill the speed. All right, let's see what happens. It's gonna go back up there. Oh shit, okay, good. So watch the slope. Oh, this is so exciting. So obviously it looks like it's approaching. Can you guys see it? What did it look like it was approaching? 2. I like it. What happens right when it gets to 0? Oh crap. All right. Let me just stop it. Stop. Right when it gets to 0, it just kind of goes, I don't frickin' know, right? Because of course, at 0, this thing, it says undefined, but it's even worse. We know better, it's indeterminate. But it gives up, because I don't know. But so that's why we have the idea of a limit, because I have a point where something weird happens. If I go there, everything blows up, right? One of my favorite examples, real quick, just deal with me. And you're all like, that's basically what we're going to do this whole semester. Have you guys ever seen the movie The Blob from the 80s? Anybody like horror movies? I love you guys. Are you guys okay? Because it's okay. You can say, no, I hate horror movies. Don't even talk about them. And it's too bad because so this little creature crash lands into Earth. And then there's this guy, he's like, what the shit is that? So he gets really close. So this is good. This is art. He gets close. But unfortunately, what he does is he touches the damn thing. And then it goes around his arm, and it eats him, and then it goes and eats all these people. Anyway, right? That's basically every horror movie. So what we want to do with the limit is we want to be smarter than that guy. It's like, what is that? Okay. So get really close and go, I have no idea what it is. But I can kind of, as I get closer, I can kind of tell more and more about it. But I don't want to get there, because then, right? All right, maybe I like that example. Maybe it's just for me. So that's what limits do. This is a very specific use of a limit. So limits exist by themselves. This is one place I can use the idea of a limit. Maybe? You guys know? Maybe? Okay. All right. Maybe. All right. So I kind of want to, yes, I want to get us ready for this handout that I've got. Is that what I'm writing on? Yes, it is. So let me, oh crap, I've used many of these. All right. Let me make sure I'm going to do, okay, good. So yesterday, we talked about things like this. Oh shit. Not yesterday, you know what I mean. Let's see. Where is my... I don't know where you are. Oh well, okay. So we talked about this kind of thing here. So if I have a function doing this kind of thing, that's a really freaky looking function. Okay, if I've got something doing this, what is the limit? Oh, this kind of sucks. What's the limit? I know what I'll do. I'll be semi-smart. What is the limit as x goes to -2 with a little negative sign? What does that mean? We'll call this g of x. Yeah, the little negative sign above the -2 means it's coming from the Let. I like it. So what is that limit? So as my inputs approach -2, what are my outputs doing? Approaching 1. I love it. Okay, I like it. What's the limit as x goes to -2 from above? Or from the right? Yes. So now again, as my inputs approach -2 from the right, I'm looking at what my outputs are doing, and they seem to be approaching -2. So is there a limit? How are you going to do this, Jeff? I'll figure it out. Is there a limit at -2? Period. Of course not, because they can't agree. How can I say there is a thing when they can't even agree, right? What do you think the color is blue? What do you think the color is red? Well, what's the color? I don't freaking know. We don't have agreement, right? Okay, I like it. So this one we call, do you guys remember what we say here? Good. Does not exist. Don't know enough. No, does not exist, right? Okay. So then, but what is F? Gather F. What is G of -2? Yes, good. So you just, that's where it matters what it is at that point. The limit doesn't give a shit what it is at that point. It's not even that it doesn't give a shit, it just doesn't ever get there. So it would have no idea what it is. But the function value there is 1. I like it. This is a jump discontinuity, which is kind of nice name. If I could just write, maybe you could tell what I was saying. Jump discontinuity. This one, what's the limit as x goes to 1 of g of x? 1. Why does that limit exist? It agrees from both sides. I like it. So there's agreement. So there is a value it's approaching, period, meaning from above and from below. Where'd it go? Here it is. What is g of 1? Undefined. I like it. Kick ass, right? And of course, this one, it would be all the same kind of ideas, except it does exist. Okay. I like it. So that's nice. The visual aspect is nice, right? Limits are nice when they're visual. Let them be nice when they're visual, I should say. All right. So there's this idea. So what does it look like when I don't have a visual? We did one like this the other day. Let me see if you guys remember this. What do you got, Jeff? Let's do... Why are you going to make it weird? Because I'm a math teacher. Okay. It's not weird. It's fine. So the first thing you want to do when you see this kind of problem is plug 1 in. Because here's the neat thing about, what kind of function is this? What kind of function is this? So it's a fractional function, right? That's not the right word. So when I have a fraction, a more technical way to refer to it is a what of 2 numbers? Starts with an R. Ratio. So this is a rational function. Rational, right? It's a ratio of 2 polynomial functions. That's a rational function. Rational functions are nice everywhere except the values that aren't in its domain. So of course, which value is not in this guy's domain? 1. So I can plug shit in until it's got a problem at that point. So you got to be real careful. Some problems that gives you, there's not going to be a problem. You just plug it in and you're done. You get the number, you're done. But is there a problem at 1? Obviously yes, but what's the top at 1?
0.
0. Okay. Right? 1 plus 1 minus 2. Yeah. So this is 0 over 0, which means I have work to do. Because I cannot determine what that is. That's why we call it indeterminate. I like it. So this is what's called an indeterminate form. Indeterminate form. Indeterminate or indeterminate? I don't remember. Okay. So here's the beautiful idea. There's a problem in this thing at 1. Can we remove the problem? Yes, because obviously what can you do at the top of this? Factor the bad boy. And of course, how do you factor that sucker? I'll bet you there's an x minus 1 in there. And then of course it's x plus 2. Die. Why am I allowed to do that? I really want this understood. You are allowed to cross that out everywhere except when x is 1. Does the limit ever let x be 1? No. So that is why I'm allowed to do that. And not really change the problem. Do you guys... If you were supposed to graph this thing and you killed it and then you just graphed x plus 2 the line, would that be right? No. But here I could totally just screw that part because I'm not ever going to get to 1. Okay, I like it. So of course now I can actually do it, can't I? When I plug a 1 in, is there a problem now? No. So now maybe I understand where that 3 came from earlier. You don't get that far ahead. Stay with me. Okay. But I appreciate that. Okay, so if you were to graph this, there would be an open circle at what point? 1, 3. I love it. It wants to be at 3. It's not allowed to be there. So you would just put an open circle. Everywhere else it's allowed to look like x plus 2 except right there. Kick ass. All right, let's try a freakier one. Let's see. If I try to make one up in my head, I'm going to freak it out. Okay, here we go. This is perfect. Limit as... Okay, mask. Work with me. Sure, we'll use this. T goes to 0. No, that's not. Oh, yeah, let's do this. Yeah, okay. Sorry. Oh, man. Why, Jeff? So is there a problem at 0? How big is the problem? I kind of want this. No, I should have made this. Let me do this. Can you guys make it like this for a second? And then we'll do the one I just wrote. Okay, put a plus there. All right, this is determinate. I can get the answer without doing anything. Instead of thinking a little bit. So the bottom is 0. What's the top in this problem now? 6. What's 6 over 0? We can be smarter. When the bottom is getting tinier and tinier and the top is approaching 6, what are the outputs doing? 6 divided by 1, 6 divided by 0.1, 6 divided by 0.01. It's going to infinity. I like it. So technically, it does not exist. There is no limit because it goes to infinity. So that kind of makes sense. But we can be more specific. This goes to positive infinity because the top is positive and the bottom is 0. So I really want you guys to understand, I only have to do some algebraic work if it's in an indeterminate form. The only indeterminate form we know right now is 0 over 0. I don't know what the shit that is. So what about this? Come on, Jeff. Jeff! Sorry. I love that. I don't normally yell at myself, but I do talk to myself. Okay. What about that bad boy? Yeah, that was nice. I mean, what form is this in? 0 over 6, which is 0. Kick ass. So before you start doing all kinds of weird ass algebra or conjugates or weird shit, plug the value in. See if there's an issue. See if you can't determine the answer, then you have to do more. I like it. So let's go back to the original way I had that. Where'd it go? There we go. I kind of gave away the answer to what you do if you were listening just a second ago. I think we talked about this before, right? Do you guys know what to do with this thing? So it is indeterminate. Oh shit. Oh shit.
Like if we want to simplify.
Sort of?
I'm trying not contradict.
Yeah, there it is.
Okay.
Yeah, which is not really simplification.
Okay.
Do you understand what I'm saying? But it is something I need to do.
Okay.
So the conjugate, it's really interesting. We're so used to like rationalizing the denominator. You guys remember doing those? 7 over the square root of y, you multiply by square root of y, so the bottom's not freaky. So we normally do the denominator. But with this problem, I'm going to try to do a conjugate to see if I can kill the problem. That's really kind of like the whole idea with a lot of these we do by hand is, there's a problem, can I kill it? Right? If I can kill it, there's no problem. I can plug shit in, get the answer. So what will the conjugate be?
T squared plus 9 plus 3.
Yes, root t squared plus 9 plus 3. It's just the difference of squares, buddy. Right? And what you want to do is you never want to multiply the bottom stuff here, or whatever the one that isn't the conjugate one. You want to keep those apart. So on the bottom I get t times this mess. Pretend like that's a t. What do I get on the top?
T squared plus 9 times 3.
Say, I'm sorry?
Just t squared plus 9.
Well, we get t squared plus 9 minus 9.
Oh, yeah. Okay.
Right? Is that cool?
Minus 9.
And the middle terms cancel, so I can ignore them.
Yeah.
It's kind of like what we designed it to do. And then what happens here? Look, the problem is disappearing, right? Die problem. I really want you to get that. I'm doing this work in the hopes that the thing that wasn't letting me plug the value in cancels. That's what I'm hoping happens. And now what do I get when I plug in 0? I just get 0. I love it. 0 to 6, I get 0. Sweet. Okay, that's not too bad, right? You do have to remember some algebraic stuff. All right, one more, and I'm going to unleash you on this. I'm sorry, did you guys get all that? Everybody? Okay. One quick one here. Limit as y goes to 0 of y minus the square root 3 minus y over, what do you got, Jeff? Y plus 1. Don't say anything. I like that. Hey, don't say anything. All right, if there's anyone out there that's doing any work at all, you've forgotten the first step. What's the first step? Put a 0 in.
Yeah.
What do I get when I put a 0 in? Negative rad 3 over 1.
Yeah.
I'm done. All right, so really, I hate it. I really feel bad when I put a problem like that on the quiz or something. Somebody does all this work and like, man, you made that quiz long. I'm like, no, I didn't. Right? The first thing you do is check, is there a problem at that input? If there isn't, I don't have any work to do. I'm done. Right? I don't have to do any weird work. Okay, so let me give you this. It's on me. Oh, good. All right. I want you guys to work on this, and I'm going to let you check your answers with people near you, and then we'll do this together. Go ahead and do as much as you can. Then I'll let you check your answers with people near you, and then we'll do it together.